Okay, I want to show you how you can use your calculator to do parametric equations. So the first thing we got to do is we got to go to the mode and come down here where it says functions, function parametric polar. We're going to select parametric. So I move over to that and hit enter. Now I'm in parametric mode. Several things happen when you're in parametric mode. One is that this button here, that x, comma, t, comma, theta, comma, n, now is a t for parametric mode. The other thing is when I click on the y equals, it doesn't look like y1, y2, y3 anymore. It's x1, y1, x2, y2, x3, y2. So this is where we enter our parametric equations. So let's see, the first example I think we did was 2t, x equals 2t, y equals, oops, what am I going to do? Hit enter. Y equals 1 minus t squared. Okay. So I used this t squared. I used this as our first example. I want to take a look at it here on the graph. Some things to notice. Here I'm going to draw the graph. Is it's drawing the right-hand side. Well, click on the window button. The window button shows you what's going on here. I'm going to scroll down and notice it has the x min, x max, y min, y max to define the window. But also in here it has this t min, t max, and t step. And this is kind of like we had in polar coordinates where we did it with theta. These are the values of the parameter t that you're going to use. You're going to start from t equals 0. And this apparently they have it up to 2 pi. That's the default, and steps of something weird here. So let's see. When we did it in class, we went from -2 to 2. -2, enter 2. I'm going to go in step sizes of 0.1. Okay, and draw the graph. And you can see there's the piece of the curve that we had. Okay. Some things to pay attention to. First of all, the smaller the step size, the more you have to wait for it to draw it. So if I go to step size of 0.01, it's going to increment t by 0.01 every time and then plot another point, and it goes a little more slowly than it did for the previous one. If you get your step size way too small, sometimes you find yourself waiting and waiting and waiting. Just press the on button. That will stop whatever it's doing, and you can go up and change that t-step to something bigger. On the other hand, if you make your t-step too big, oops, how do I do this? Down, make it like 1, then what happens is you don't plot often enough, and it looks less smooth. Okay, so take a reasonable sized t-step that will get you your graph fast enough, but and be reasonably smooth for the graph here. So I like 0.1. Yeah, some other things here. You can do more than one at a time. So let's do that one, and then let's move down and type another one. Let's do a big circle here. How about something like 4 times the cosine of t for x, and how about 4 times the sine of t for y. Draw the graph. A couple things I noticed. One is it didn't draw the whole circle, and 2, it looks like an ellipse. And so I think that's a matter of my zoom. If I do a zoom square, then circles will look more like circles. Let me just type 5. There we go. And it's like, why did it not draw the whole circle? Well, I'm plotting from t equals -2 to +2. And in that set of equations here, t is being used like an angle. So it's going from minus 2 radians to plus 2 radians, which isn't all the way around. So if I go change my window now, let's go from negative pi to pi. Then maybe it'll go all the way around. Let's see here. Draw the graph. Notice it drew more of the parabola as well. Right? Now, in some of the exercises in the book, they ask you to draw smiley faces and things, and we'll do some examples of that. But it's a little tricky on the calculator because every single plot uses the same t-values. Right? In this example here, t is going from minus pi to pi, and so it's drawing both the parabola, minus pi to pi, and the circle there with the t-value going from minus pi to pi. Okay, just something to be aware of. There you go. There's the basics of using parametric equations on your calculator.